Okay, now let's do a couple practice problems with kinematics in one dimension. Starting off, first question, a boat accelerates from 19 meters per second to 43 meters per second in 41 seconds. How far does it travel during this time? So, what's our strategy for solving one-dimensional kinematics problems? First step is always to evaluate what is given, what variables are given, and what variables we need to find. So step one is to organize our variables. Okay, so let's do that here. What do we have? Well, we have an initial speed that is 19 meters per second. Here, let me do in a darker color here. V1 equals 19 meters per second. What else are we given here? We're also given a final velocity, 43 meters per second. And finally, we are given a time. T equals 41 seconds. So I always want you to organize your variables like this. You look at the question and dig up the variables that you're given and write them out here. And then in the question, they're always asking you to find the fourth variable. So here it's asking for how far does it travel. So it's asking for a distance, that is delta D, and that we do not know. Okay. Step two, now that we have organized our variables, the next step is to determine which equation we want to use. Determine which equation to use. Now let's go back to our list over here of possible equations and keep in mind that we have four variables in this problem: V1, V2, a time, and a displacement. So which equation covers all four of those? And if you said equation 4, you would be correct. So we got V1, V2, displacement, and a time. In this question, we're not given an acceleration, and we don't care about acceleration in this problem. So equation 4 is the one we're going to use. So therefore, use equation 4. After we've organized our variables, determined which equation we want to use, moving on to step 3, and that is to start plugging in variables to our equation. So here we have our equation. I'm just copying it over from the list beside us. And I have one more note to make, and that is I have called this equation number 4, but in your textbook or in the sheet that your teacher gave you, it might be associated with different numbers. So the number's not the important part, it's the actual equation itself. You might also have them, your equations rearranged differently. Like this equation could be written in terms of t, but regardless, there's 5 unique equations, and so I want you to focus more on the equation, not the number itself, because depending on where you're looking, you might be a different number associated with it. Anyways, back to step 3. We're plugging in our known variables. So here we are looking to find delta D. We're not sure the value there. And we have, for V1, 19 meters per second, V2, 43 meters per second, and our time, 41 seconds. So all we have to do now is keep simplifying this. Also, make sure to keep track of your units. Make sure that they're being consistent and that you're just holding on to the meters per second and the seconds over here. And we'll make sure that they cancel out appropriately as we continue. So we have 15.5 meters per second multiplied by 41 seconds. That means our seconds cancel out, and we are left with an answer of 635.5 meters. And for our final answer, we want to keep just 2 significant digits because that's all we're given in the problem. So in terms of 2 significant digits, here we have 6.4, and we're moving this back here. This decimal goes 2 spots back, so times 10 to the 2 meters. That is our final answer for question 1. Now let's do the same thing with question 2. So step 1, as always, organize our variables. So let's take a look. Here we're given a V1, it's 23 meters per second, and at your first glance, it might look like that is the only information we're given in this question. There's no other numbers here. We don't know. We're not given anything else. So what we have to do in this case is think, okay, is there any other data that's given indirectly? And one piece of information that's commonly assumed but not necessarily provided in the question is the gravity on Earth. So gravity on Earth produces an acceleration of negative 9.81 meters per second squared. That's towards the ground, so that's why we call it negative, because it's down. So that is a piece of information that they won't necessarily provide in the question, but you're just supposed to we're supposed to just know that. So this is one of those values that you'll need to memorize. The gravity produces an acceleration of negative 9.81 meters per second squared. Okay, so we got 2 values. We're going to need one more. Where can we find it? Well, reading the question again, a ball is thrown up straight in the air, 23 meters per second. How high does the ball reach? What we know here, when the ball reaches its maximum height, so when ball reaches max height, you can draw a little diagram of this. The ball is thrown straight up in the air, and then it comes back down. So it's thrown up with an initial speed of 23 meters per second. when the ball reaches the top, what's its speed? Well, its speed at the top is 0 meters per second. And then it starts coming back down again. So we actually also have another piece of information here. That is V2 is 0 meters per second. So you can see, remember, the ball follows its trajectory. It's thrown straight up, comes to a speed of 0 meters per second, and then comes back down. So when we're asked to find the max height, well, that's right here when the velocity is 0. So when ball reaches max height, velocity equals 0 meters per second. And that is a known piece of information that we are going to use. And then what's the question? What variable are we looking for? Is the height that the ball reaches, which is displacement. Okay, step 2, choose our equation. So keeping in mind the variables that were given, V1, A, V2, delta D. Which equation are we going to use? Well, equation 5, V1, V2, delta D, and A. We don't care about time in this question. So let's use equation 5. And again, your textbook or your teacher might have different numbers associated with these equations, so just look at the actual equation itself. Don't focus too much on the number here. So we have chosen, or we have picked to use equation 5. Moving on to step 3, we're going to plug in our known values. First, I'll just rewrite the equation. Now let's plug in our values. And I'm doing these in a different color just so it's easy for you guys to follow along. Meters per second. And acceleration. And this is the variable that's unknown, but we're trying to find. So let's just continue on with this and simplify a little bit. So 0 meters per second equals 529 meters squared per second squared minus 18.62 meters per second squared. And still we have one unknown, and that is delta D. So in this case, so far we've followed our steps for question 1, but in this question we're going to have one extra step because we have to rearrange we need to solve for delta D. So we need to rearrange and isolate delta D on one side of the equation. So rearrange to isolate unknown. And the unknown here is our delta D. All right. So 18.62 meters per second squared, delta d is equal to 529 meters squared per second squared. So you can see what we did here. We moved this term onto the other side of the equation. So when we switch the side of the equation, we have to change the sign. So our negative on the other side will be a positive. So this is plus 18.62 times delta d is equal to 529 meters squared per second squared. And then if we just isolate d by dividing both sides by 18.62, that gives us our simplified equation that we will just plug into our calculator to find that delta d is equal to 28.4103 meters. And in our final form, we just want two significant digits. That is our final answer for part 2. All right, moving on to question 3. Here we have a huge pink rocket ship accelerates at 28.4 meters per second over a distance of 3,001 meters in a time of 29.0 seconds. What velocity does this insanely massive pink rocket ship reach? Now we're going to follow the exact same steps as our last 2 questions. Step number 1, if you remember, is to organize our variables. So let's take a look here. First one is our acceleration. And you'll notice an explicit acceleration is not given in the question, but as long as we are on planet Earth, we know that the acceleration is negative 9.8 meters per second squared. And again, that's going to be a value that you are going to be expected to memorize and know by heart. Then our second variable that we are given here, so 3,001 meters as our delta d. And then our time. Oh, my apologies here. The acceleration was not negative 9.81 meters per second squared. We actually are given an acceleration. I should have caught that earlier. That was my mistake. We were given an acceleration in the question because our rocket ship is accelerating upwards. My apologies there. So that's been fixed. And then the last variable that we're given is our time, 29.0 seconds. And the question is asking, what velocity does this insanely massive pink rocket ship reach? So that is asking for V2. Sorry, I forgot the 1 on step 1 there. So step 2 is to choose an equation. And to pick an equation, we're going to, again, look at our variables that were given. So acceleration, displacement, time, and final velocity. And looking at that, and which equation are we going to use? Well, we've got final velocity, displacement, acceleration, and time. So we're going to use equation number 1. So use equation number 1. So moving on to step 3. To plug in our variables. So again, let's write down this equation first, just as it is, just so you guys are getting this equation drilled into your minds. You want these equations to come second nature. If you can memorize them, that would be great. You'll make your tests that much easier if you got all these equations memorized. But anyways, the more you practice, the easier these will come. So let's start plugging in variables. So what is our distance? Well, it's 3,001 meters. Our final velocity, we don't know. That's what we're trying to find. And the time is 29 seconds. Then we have an acceleration and a time again. So time again was 29 seconds, and our acceleration is 28.4 meters per second squared. And again, let's just simplify this a little bit before moving on to step 4. We can just kind of clean up this mess off to the right. If we plug this into our calculator, you should get the same answer as I do here. I recommend you try this out just to get a little bit of practice. Alright, I'll keep this green just so we can keep track of our unknown variable. That leads us to step 4, where we want to, again, just like the problem above, rearrange to isolate the unknown. So isolate the unknown. So here on this first line, we're just moving our big mess here on the right. We're going to move it to the other side of our equation. And you'll see that here. Just to simplify things, we want to have our unknown variable, that's v2, on one side of the equation all by itself. So to do that, again, we're bringing this mess over here to the other side. And I have just mirrored the equation, but it's the same equation. So when we're moving this to the other side, it becomes a plus. This is staying, so it becomes a plus, and then our v2 is also staying, so it is staying a positive. Now the next step here is going to be to get rid of this 29 seconds by dividing it. We'll be dividing it away. So when we divide both sides by 29, that eliminates it with the v2, and our equation becomes 3,001 meters plus this mess of meters all over 29 seconds. Now I hope you can see these units lining up. We got a velocity and our units are lining up to be meters over seconds, so that is always exciting. That's exactly what we're hoping for. Now we just have to type this into the calculator. It'll give us an answer of 515.2827586 ... It goes on forever, meters per second. And obviously, in our final answer, we don't want 1,000,000 digits. As we look in our question, everything's given to us in 3 significant digits or 4. So our final answer will be in the lowest number, that is 3 significant digits, meters per second. And if you join us next time, we'll be doing just a couple more examples similar to this with one-dimensional kinematics.